Hey, this is Mrs. Kreider, and today we are going to do a couple of bell work problems, and then we're just going to spend the rest of the time reviewing some of the questions that I pulled from your last three assignments, some of the tougher, the more tricky ones, and we're just going to spend all our time working on those. So, we'll do first these two, 30, 60, 90 and 145, 45, 90. Let's start with the 30, 60, 90. And we know it's 30, 60, 90 because this is 90 as evidenced by the right angle marking. And then since 90 plus 30 is 120 and all three angles must add to 180, we can deduce that this angle has to be 60. So we're going to go ahead and stick with that. And then we want to look at the patterns. So we know that in a 30, 60, 90, we have a short leg, okay, a short leg, a long leg, and then the hypotenuse. Okay, so if we have a short leg, a long leg, and a hypotenuse, we need to figure out which of those goes where. I always start with the hypotenuse. Okay, because the hypotenuse is across from the right angle. So if you start at the right angle and go to the other side of the triangle, that's always going to be the hypotenuse. And then from there, we know that the short leg has to be across from the smaller angle, and the long leg has to be across from the longer angle. So that makes this side the short leg, and this side the long leg. So the long leg is y, the short leg is 6, and the hypotenuse is x. And we need to find x and y. So if you remember a triangle like this, and you can always dot it out if you want to, and this is a terrible drawing, I apologize, you can sort of turn it back into an equilateral triangle, which means all three sides of that equilateral really equal x. And this short side is really half of x, okay, because it's that little piece that gets cut in half. So if that short side is half of x and it's 6, then the hypotenuse has to be double. Okay, so that has to be 12. And then the short leg times the square root of 3 is always going to be our long leg. So the long leg equals the short leg times the square root of 3. And so this is going to be 6 times the square root of 3. So those are our two answers, 12 and 6 square root of 3. Notice we did not do any Pythagorean theorem. Any math. And if you look at that, you could, once you figure out the 6 and 12, you could still do the Pythagorean theorem. But if you can just remember that short leg times square root of 3 relationship, it just makes this problem so much simpler. Let's make that smaller again. Okay, now let's look at the 45, 45, 90. I know it's a 45, 45, 90 because this is 90. And it's not marked, but I promise that's a 90-degree angle. And you know what? I'm looking at this. You probably didn't realize that beforehand, that that's a 90-degree angle, but we would definitely treat this as a 90-degree. Oh, you do know, because if these are congruent, that means these legs are congruent, and that means these angles have to be congruent, which means this does have to be a right angle. So even though it wasn't marked, you could actually figure out that it is 90 degrees. In either case, we know that it's the leg times the square root of 2 equals the length of the hypotenuse. So this one looks a little weird because the leg is the square root of 3 already, but that's okay. We can multiply the square root of 3 times the square root of 2, and that's all we have to do. Remember that in a 45, 45, 90, we have our x, and then x square root 2. I don't know why I'm getting weird extra markings on here. I apologize for that. X, and x squared root 2. So if this is our x, then it's just the square root of 3 times the square root of 2. And remember, when you're multiplying radicals, you can just multiply the numbers together. As long as they both have a radical, then you can just multiply them together and put the product under a radical. So that would equal the square root of 6. So that question is square root of 6 for the length of the hypotenuse. All right, let's go ahead and move on to our next slide, and I have created for you here a little summary chart, and I'm going to ask the substitute to pause the video here and give you just a minute to process the information that you're looking at. For the 45, 45, 90 degree triangle, I did this all without the x and the symbols, and I want you to look at it in terms of the length of the legs and their relationships to each other. So we've talked about this before, that when you have the 45, 45, 90 degree triangle, the length of the leg, and here I'm just going to quickly change my pen tool. The length of the leg is always going to be congruent for both legs because it is an isosceles. Okay, that's actually going to be a right angle as well. We'll mark both of those. And then the hypotenuse is always just the leg times the square root of 2. Okay, so easy enough. So the hypotenuse equals the leg times the square root of 2. The tougher one happens when you're given the hypotenuse and you need to go backwards to find the leg. And it's especially tough when the hypotenuse is not something multiplied by the square root of 2. So that can actually cause some trouble. Now, it's really actually pretty easy though, because if you had to multiply by the square root of 2 to get the length of the hypotenuse, you can just divide by the square root of 2 to get the length of the leg, just reversing the process. The trick is right here. We are not allowed to leave a square root of a number in the denominator of a fraction, so we have to go through a process called rationalizing. And when we rationalize, it's just going to end up with the radical on top. And let me give you a quick example. If I had a number like 3 divided by the square root of 2, I can't have that square root of 2 in the denominator of my fraction, so I'm going to rationalize, which means I'm going to multiply by a fraction, and that fraction has to have the value of 1, because I can multiply any number by 1 and the number doesn't change. Now, if my 1 looks different than the number 1, like if I have a fraction like 3 over 3, 5 over 5, square root of 2 over square root of 2, those are fractions that all equal 1, and they may change the way my number looks, but they don't change the value. And that's what we're trying to do. We want to change the way it looks. So we are going to multiply by the square root of 2 over the square root of 2. And I picked the square root of 2 on purpose because I know that when I multiply this out, actually I'm going to work down here. When I multiply this out, the square root of 2 times the square root of 2 is going to be the square root of 4. And we know what's going to happen next. That's going to simplify. On the top, though, we have this 3 times the square root of 2. So one more step of simplification, end up with 3 times the square root of 2 divided by 2. So you can see here it's the hypotenuse, back to this slide right here, the hypotenuse over 2 times the square root of 2. So if this had been our hypotenuse, we would have had to divide it by the square root of 2, and when we're done, we would have just had the hypotenuse over 2 times the square root of 2. Okay, so that's rationalizing. Now, there's also a pattern to rationalizing, and that's why you're able to look at this and just say, oh, just divide the hypotenuse by 2 and multiply by square root of 2. Okay, so this is a lot of information. It just takes practice. Practice, practice, practice. Let's look at the 30, 60, 90. We have 3 different labels to make for a 30, 60, 90. We have the hypotenuse, and then since these two angles are not congruent, we have one leg longer than the other. So we easily, just to make it simple, we call one the short leg and we call one the long leg. We know that, oh, look at what I did here. I completely labeled this backwards. Do you see what Miss Kreider did? Whoops. That's the hypotenuse right there. And that is the long leg. Some of you were probably looking at that and thinking, what was she doing? There we go. Fixed. So the hypotenuse is always 2 times the short leg. Here's the short leg. Here's the hypotenuse. Remember the half of the equilateral triangle thing. That makes sense that this would be half of our hypotenuse because it's half of the original triangle. So the short leg equals half the hypotenuse. If we're given the short leg, we just double it to make the hypotenuse. If we are given the short leg and we need the long leg, we just multiply the short leg times the square root of 3. Those 3 are pretty easy. If they give you the long leg only, and I guarantee you're going to see a problem like this, if you know the long leg only, you are going to divide it by the square root of 3. And then to do that, you're going to go through the process of rationalizing once again. So if, for instance, and we'll go through an example of it, but if you were given the long leg and it was a number like, 3, then you would get 3 divided by 3 times the square root of 3. and then it would end up just being the square root of 3. So those are pretty easy. They're just more algebraic. So let's go ahead and move on to some worked out problems. Some problems to work out. So slide on down to the next example. So these are special right triangle examples, and we're just going to kind of go through these pretty quickly. Just talk to your substitute. We can pause, go back. This will also be posted on Edmodo and on my YouTube channel so that you can go back and watch these slower and work them out yourselves. But these are all problems straight from your practice worksheets that as I'm looking through them, I'm noticing lots of students are struggling with these. So we're just going to pick a handful and go through them. Starting with this first one. This says 45 degrees and I have a 90-degree angle. That means this also has to be 45 degrees, and that means these two sides are congruent because I'm looking at an isosceles triangle. Let's talk a little bit about why we know that's 45 degrees. We do because if this is 90 and this one is 45, together they equal 135. Well, since they all have to add up to 180, 180 minus 135 is equal to 45. So I know that's 45 degrees. So let me go ahead and get rid of that so that we can do the rest of our work. So if this is an isosceles triangle, then that means B is congruent to the given leg. So B equals 2, it's doing it again, sorry, 2 times the square root of 2. Now, if we know that the hypotenuse A, and remember that rule, the hypotenuse equals the short leg, or the leg rather, times the square root of 2, all we have to do is sub it in. So A equals 2 times the square root of 2 times the square root of 2. We're just multiplying that given leg times the square root of 2. Easy peasy. A equals 2 times the square root of 4, because the square root of 2 times the square root of 2 is the square root of 4. That's a 2. And that's really just 2 times 2, which is equal to 4. So A equals 4 in this problem. I did not see a lot of 4s, and in fact, I'll call your attention to a common error that I saw. I saw a lot of students marking this side not congruent to this side. That's a big tell. That information, you had to do a little bit of deductive reasoning to make sure that you marked B as 2 times the square root of 2. So something to be on the lookout for. Okay, let's look at this one where they've given you the hypotenuse and we have to work backwards to find the leg. Once again, we know it's a 45, 45, 90 triangle, and we've already been through y. So we know these are congruent. That means y equals x. So once we find y or x, we know that it's the same. So we know the hypotenuse. Okay, the hypotenuse is 2 times the square root of 6. And we also know that the hypotenuse, or the hypotenuse equals the leg times the square root of 2, which means if we know the hypotenuse and we need a leg, then we have to be able to solve. So it's going to be the leg equals the hypotenuse divided by the square root of 2. And that's the one we had to rationalize. So it simplifies out to the hypotenuse over 2 times the square root of 2. So using the pattern and not having to do any real math, we can just say the leg equals, we can substitute in now, x equals half of the hypotenuse, so 2 times the square root of 6 divided by 2, and then times the square root of 2. So we can do a little bit of simplifying here. These are going to cancel out because we're multiplying this together, so that's allowed to cancel. And that gives us the square root of 6 times the square root of 2, which is the square root of 12. And that's not in simplest radical form, so we need to break that up a little bit more. And breaking up a radical and simplifying it is a skill that we definitely need to work on. So we want to look at pairs of numbers that multiply to 12. I always start with 1 and then just build my way through. 1 and the number are never going to be helpful. So 2 and 6, that doesn't work because neither is a perfect square. 3 and 4, and that one is our pair because 4 is a perfect square. So we can rewrite that radical as the square root of 4 times 3. And I do that on purpose because when I break it up, I want the number that's going to come out. So that's going to be the square root of 4 times the square root of 3, and x equals 2 times the square root of 3. So x equals 2 times the square root of 3, and y equals 2 times the square root of 3. Okay, so those are those two. Let's go ahead and go through a couple more examples that I have for you. And we'll switch to purple just for fun. Mix it up a little. Okay, a 30, 60, 90. And we are given the long leg. So this is that tricky one I was talking about. We were told, and if we go back to our little rule here, let's go back to that diagram that shows the rules. This one. Okay, if we know the short leg, I'm sorry, if we know the long leg, if we need the short leg and we don't know the hypotenuse, then we just have to do the long leg divided by 3 times the square root of 3. So we're just going to go straight for the pattern on that one. Okay, let's go back to our problem. So we know that it's going to be the long leg divided by the square, divided by 3 times the square root of 3. So if our long leg is 12, then we're going to sub that in. So it's going to be 12 divided by 3 times the square root of 3. And since 12 divided by 3 reduces down to 4, we get 4 times the square root of 3. So our short leg is 4 times the square root of 3. The hypotenuse is always 2 times the short leg. So it's going to be 2 times y, which is going to be 2 times 4 the square root of 3. 4 times the square root of 3. And that's going to be 8 times the square root of 3. Common error here is to add those, but this is a multiplication symbol, so you want to multiply. So 8 times the square root of 3 is our answer for the hypotenuse. Okay, that's a bear. That's a tough one. Practice that a few more times. You have a couple more examples like that. Go back and rework those and get that practice. Okay, this one is another 30, 60, 90. It's a little bit easier. Don't let the radical throw you off. This has a hypotenuse that is 2 times the square root of 2, a short leg that is b, and a long leg that is a. Whenever I know the hypotenuse or the short leg, I can always get the other one. So I know the hypotenuse, I just have to cut it in half to get the short leg. Okay. So we have short leg equals 1/2 of the hypotenuse, or hypotenuse over 2. And that's going to be 2 times the square root of 2 divided by 2. Okay, I should have just written it as hypotenuse over 2. And then those are going to cancel. So the short leg is just going to be the square root of 2. So b equals the square root of 2. And we now need to, for the long leg, equals the short leg times the square root of 3. So that's just going to be equal to a is going to equal the square root of 2 times the square root of 3. And that's going to be the square root of 6. So just take a look at that and ask yourself if the square root of 6 can be simplified. Make your pairs if you need to. 1 times 6, 2 times 3. Nothing is a perfect square there, so this one can't be simplified. So a is simply the square root of 6. Okay, and you're done. Those are your answers. All right, these are challenging. I understand that, but just practice, practice, practice. Email me your questions. Come visit me at my office. Ask Mr. Jag if he's your substitute. He's very helpful. But just make sure you're reaching out and asking the questions. Don't let yourself get frustrated. This is a 45, 45, 90. And again, we are given the hypotenuse. We need the legs. N is going to equal M because it is an isosceles 45, 45, 90. That's a 5, not an 8. Okay, these are congruent. So we are given the hypotenuse. We know that if we were given a leg, we would multiply by the square root of 2 to get the hypotenuse. Since we're given the hypotenuse, we're going to divide by the square root of 2 to get the leg. So the leg equals the hypotenuse over 2 times the square root of 2. That's that pattern we showed at the beginning. That's after rationalizing, so we're just going straight for the pattern. Okay, so that's going to be 7 over 2 times the square root of 2. Now, it's really tempting to write this as 3.5 times the square root of 2, but it's not good form to mix decimals and radicals, so we're just going to leave that as 7 over 2 times the square root of 2, or we could rewrite it as 7 times the square root of 2, all divided by 2. Those are going to be equivalent forms. All right, let's take a look at some trig practice problems. And I've got a couple for you. Let's give you a little summary, reminder of the trig ratios. Remember your SOHCAHTOA. This is a way I like to write it out because you can still read it as SOHCAHTOA, but you can actually see those fractions in there. I find this to be very visual and helpful. You still want to remember your mnemonic device. Some old horse came a-hoppin' through our alley. You can also do the little, what happens to Chief, the Indian chief when he gets stepped on by a horse. He has to SOHCAHTOA. I mean, goofy joke, but if whatever makes it stick in your brain, it's not goofy anymore. All of a sudden it has purpose. So these are your three main trig ratios. There are some other ones that we're not going to worry about just yet. These are the three main ones. And notice for each one of them, they reference an angle. Okay? They reference an angle. So I've given you two diagrams with the reference angle marked with a star. So the reference angle simply means that we're going to label the parts of the triangle, the side lengths, based on which angle is our reference angle. So in this first diagram, where our reference angle is here, the star, then the side that is opposite to our angle, if we have to travel across the triangle to get there, is going to be the opposite. The hypotenuse can always be labeled because it's the opposite of the 90-degree angle, and then that leaves us our adjacent. Okay, and if you switch the reference angle to the top of the triangle up here, then you have to switch the opposite and the adjacent. Notice the hypotenuse stays fixed because it's always across from that right angle. And then the opposite is across the triangle, and the adjacent is next door. Notice that the sides of your reference angle are always formed by the adjacent and the hypotenuse. If you wish, you can start with those two and then do the opposite last. It's up to you to find, what makes the system work for you. We also want to touch base on those inverse trigonometric ratios, and these are what you use when you're solving for the angle measure. So when we want the angle, we are going to inverse that ratio. Okay. All right, let's go through a couple of examples. Now, you have until Monday to turn in your packet for these trig ratios, and I'll take a look at them, and if we need more practice on them, we'll do more practice. So don't stress. Just give it your very best effort, and then we will make sure that you are where you need to be when you are ready to test on this material. So we want to solve a right triangle. We have an angle measure that's given. We have one side listed and we have one side missing that we need. We're going to need a calculator for this. So in a minute I'm going to pull one up and show it to you on the screen. But for right now, let's look at the reference angle. Okay, so 72 is our reference angle. And remember that I'm going to go, first is hypotenuse, which is always the longest side, and it's across from the right angle, so that's our hypotenuse. And then we also have the opposite side, which is across from our reference angle. So the first two that I always like to do are the ones that are across from the key angles. And then we have the adjacent side, which is left over. So what we want to do is identify which trig function. There are three to pick from. How do I know which trig function to pick? So I'm going to write my SOHCAHTOA here. SOHCAHTOA. And I'm going to identify if I have the adjacent and I need the hypotenuse. I have the adjacent, I have an A, and I need the hypotenuse. So these are the two that I'm interested in. That means I need to set up a trig equation using the cosine function. So I'm going to write it as cosine of my 72-degree angle. It's always trig function of an angle. Equals the adjacent, okay, over the hypotenuse. So I'm going to sub that in. Cosine of 72 equals 6 over x. Now I wanted to show you one where the variable x is on the bottom of the fraction, because that tends to be a sticking point for a lot of students. There's a super easy way to do that, and involves just using a proportion statement. So first let's get our calculator pulled up, and take just a second to get this pulled up for you. Nope, we're going to do a trial. Okay, here we go. See if we can move that into our window a little bit better. Okay, so we want to do the cosine of 72 degrees. So I'm going to do cosine of 72 degrees, and I'm going to hit my equal. And that gives me 0.3090. I usually take it out to the 10,000ths place. 3090. Okay, 3090 equals 6 over x. From here, once I get to this point, it's sometimes easier to just put this over a 1 and turn it into a fraction. And do you guys remember what you do when you have two fractions that are equal to each other? You can cross multiply. So you can multiply the 1 times the 6, and then the 0.3090 times the x. So to continue on down here, it would be 0.3090x equals 6. And then to solve for x, I just have to divide by 0.3090. So 0.3090, and I have to do that on the other side too. 090. Okay, these two are going to cancel. And then back to our calculator, we want to do 6 divided by 0.3090. Okay, 19.42. Okay, so that equals 19.42. Okay, and it's okay to get decimals in trig. Trig gives you much more exact values, and it helps us when the numbers aren't all pretty and perfect. So 19.42 is our answer to that question. Now, let's come over to this other one and make a little dividing line because I kind of hogged too much space there. Again, let's label. We've got a hypotenuse, we've got an opposite, and we've got an adjacent. We have the adjacent side, and we need the opposite. Opposite and adjacent. Opposite and adjacent. We need the tangent. So the tangent of 37 degrees is going to be equal to x over 12. Now these are the easy kind, because when the number's on the bottom, we can just multiply both sides by 12. Okay, so we're going to get x equals 12 times the tangent of 37. And I'm going to show you a quicker way to do this in the calculator, instead of converting the angle first every time. So let me pull the calculator over to this side. We actually don't need that viewing screen. Okay, keep it a little narrower. And let's clear that last problem out. So we would just do 12 times the tangent of 37. And there we go. 9.04 is our answer to x. Okay, so do you see how we're going through the same basic problem? We're labeling. We are setting up the equation. So label, choose, set up, solve. Label, choose, set up, solve. Might want to write that down. I'll say it one more time. Label, choose, set up, solve. This time we're going to do the inverse, where you have to find the angle. And it is the same process. Label, choose, set up, and solve. So let's do it. We're going to get a little faster as we go through these. We're going to label. We've got a hypotenuse, we've got an opposite, we've got an adjacent based on this reference angle. Okay, we're going to do a little brain dump right away every time we do trig. Okay, and we're going to get that on our paper. And then we're going to say, okay, I have the opposite and I have the adjacent. That's going to be a tangent setup. So I'm going to say the tangent of my angle equals 14 over 29. Okay, now this is the one, if you go back to that other sheet that I showed you, the one that has the, I don't know where that is. It's back so many pages. This one. Nope. It's where I first introduced the trig. There it is, right there. These are the ones we're going to be using right now, where we have to do the inverse. So we're actually going to set up this equation. Okay, the angle equals the inverse tangent of the opposite over the adjacent. So let's come back over here. Goodness, how did I get to that? Okay, there we go. Tangent equals 14 over 29. So that means our angle, okay, is going to equal the inverse tangent of 14 over 29. And the good news is that with your calculator, you can actually key it in just like that. So our angle, that question mark, equals, okay, and let me scooch this over so we can see ourselves putting it in as we do it. So it's going to be the second tangent. That's how we get the inverse. You can see it in green right above the red tangent button. And then on this kind of calculator, we can simply key in the fraction like this. And there we have our angle is 25.76. I may not be rounding that right because I lost the calculator screen before I had it in my head. Okay, last one. And this one is another one. So really quickly, we're going to do hypotenuse across from the right angle. There's our reference. Opposite, adjacent. Okay, so it looks like the adjacent one is marked on the empty side, so we're not going to use that. We need opposite and hypotenuse. That's going to be a sine. Okay, so we want a sine of our question mark angle equals opposite divided by hypotenuse. Okay, so the angle itself is going to be the inverse of sine of 10 over 39. Okay, so our angle is, and then we're just going to go back to the calculator. We'll clear it out. And we want second sine of 10 divided by 39. Divided by 39. Enter. Okay, 14.86. 14.86. And that is the measure, and that's degrees. Those are both degrees. And that's how you do the inverse. So once again, this will be on YouTube. You can go find the exact place where you're struggling and just watch it a few times. Try them yourself. Try pausing and doing it yourself a step or two at a time, and then go back and watch a little more of the video. Whatever it takes. And of course, as always, reach out to me if you need help. And I'm going to go ahead and write in my information. I am Mrs. Kreider. Okay. And I am, for you Evans High School students, I'm at the top of the 500 building in the admin office. And you can email me at heather.kreider@ocps.net. Okay? Or you can message me on Edmodo. I get emails faster than I get Edmodo messages, though. All right. Hey, guys, have a great day. Have a fabulous weekend. Come back Monday ready to go. And we will see where you are and kind of take it from there. Make sure you're getting the practice you need. Okay, talk to you soon.